So we will quickly create the three databases. Okay, so we'll quickly create databases for each database will have a separate purpose. So we will create one OLTP database, one database for OLTP purpose. Okay, OLTP, where we'll assume the transactional data, day-to-day data gets loaded. Okay, so this will be an OLTP database. Another will be staging database. Okay, and then we will have one database exclusively for data warehousing. Okay, so we are going to have three database. Each of these database is having a separate purpose. Okay, in our project, right? So we quickly create the database, then we'll go and create the tables inside this database. Okay, so we'll grab some queries. Okay, so you can see you are having three queries that will create database. I will quickly execute them and create the databases for us. Okay, so we'll refresh and we have three databases. One is OLTP e-commerce database, another thing staging DB, and another, and the last and the third is data warehouse e-commerce database. So each of them having separate purpose. One is for transactional day-to-day business data. Another is staging, where when we ingest the data from OLTP, we will stage the data at a particular location, that is staging database, and then finally we will upload it to data warehouse, where that data will be consumed by reporting platforms, right? So this is three queries we have through which we are creating the database. Now we'll activate our first database, where e-commerce. Okay, so we are, this is our database where we'll load the data. So this will be the first place where the data will be available. Okay, so because it's live, we have assumed it as a live of business operational database. Okay, so everyday business transactions will be loaded here row wise, in a row wise fashion. Okay, so we'll quickly activate it. Okay, so right now there are no tables, so we'll quickly create tables for our purpose, for our project. Okay, so here I'm creating my customer table. Okay, so here is a customer table. These are the columns: customer ID, auto increment. It will automatically get incremented as records will get inserted. Then first name, last name, email, phone, city, state, country, postal code, segment. We have put a data type it as enum, so that will provide us a list of these three values: retail, wholesale, online, and by default it will be retail. Then created at, when this record was created, updated at, if there is any update in this record, that will have, it will have a timestamp of that particular date and time. So whatever, whenever it gets updated, current timestamp, whatever is there at that moment, that will be applied. Then whether it's an active or inactive data, and then we are declaring a primary key, and then we have an index key, right? So index key, what index key does, okay, it speeds up the watermark queries. So if you're going to find something based on this particular column, so index does speed up the query, right? And now these are the normal columns of customer, like from customer ID till segment. Okay, but why we are creating these three columns? Okay, as I mentioned in the previous video, that we are going to track the changes, track the data that is arriving in our project, right? So for that purpose, it's very mandatory to know when the data was created, when it was updated, whether it's active or inactive. So to track those changes, we have deliberately we are deliberately creating these columns, right? So I quickly execute. So we'll get our first table. Okay, so the table is created. Okay, so it is just a warning sign, nothing much big. If I refresh, the customer table is created. Then I'll quickly move and create my next table. That is product table. Customer is buying, will buy a product. So I'll have a product table form. Okay, so I'll paste the query. Now here we have these columns related to product. Again, it's an auto increment product ID. Here also we have three deliberate columns which we are creating: is active, created, and updated at, right? While rest of all the columns are belongs to this product table. Okay, and then we again have an index on updated column. Okay, so I'll quickly execute it. So it is also created. So product table, customer table is available, product table is available. Then we'll create table for stores. Okay, where you will get this product. Okay, where customer will go and buy it. You can also call it a merchant table. Okay, so again, here also we are creating some columns. These are attributes, and stores is entity. Okay, so all these are attributes or characteristics of this particular entity. So it will have store ID, store code, store name, store type, city, state, country, manager name, open date, when it was opened, updated at. Again, see, you have a column which will track the change when it was updated. When open date means when the store was opened or created, is active, whether it's active or not. And then here we do not have any index key. We will just have a primary key, and that store ID, which is auto incremented as the record gets inserted into the table. So quickly I will execute and refresh to check whether it is available. Yes, the store table is created, right? Then I'll go and create orders table. When a customer buys a product from a store, an order is generated, a transaction happens, it gets created, right? So here also we have order ID, order number, customer ID, store ID, order date, ship date, status. Okay, what is the status of that order, whether it's pending, confirmed, shipped, delivered, cancelled, returned. Okay, then payment method, by which payment method the customer has paid, discount percentage, any notes when this transaction was created, when it was updated, if there is a change that needs to be reflected. Okay, let's say for example it was pending, then it has become confirmed, so that is a change in the data. So to know that when it was updated, we have a timestamp. Then we have a primary key, and then we have index. Okay, apart from this we have now foreign key, so that it will refer to the customer ID in customer table and to store ID in store table. So basically, uh, when a customer goes to a store and buy a product, right, so three entities come into picture: customer, the store where he is buying, and then the product, what which product is buying, right? So when these three entities participate, they create a transaction, right? Now, whatever transaction is created, it's another entity, but that entity is dependent on the previous three entities. Okay, so here we refer this what we can say, we have created foreign key reference that will refer their primary key. Okay, to create a transaction. Okay, to create, show the participation, okay, in this entity. So I'll quickly uh, execute. Okay, it has executed. I'll refresh, and then yes, I have order stable also, right? Then Again, I'll execute order items table. I'll just simply copy paste. Again, same thing, entities and then attributes. Then again, this again table is dependent on the order ID and product ID. Okay, so what ID, because it is related with the product and the order. Items belong, or the whatever product is being bought by the customer, so it is an item. Okay, then this item is reflected in the order. That is the reason this is an order items table. Okay, so here we have a primary key, that is item ID, the product which is being bought. And again, this entity is dependent on the orders table and the product table, because these entities are participating in a transaction, that is orders table and the product table. Okay, so we'll quickly create this and we'll refresh. Yes, order items table is also available. Okay, then we'll create an inventory table. So if any product is being bought, it will reflect in the inventory. Okay, refreshed. So here also we have inventory. Okay, we have unique key with the combination of product ID and store ID. So that creates a unique, uh, uh, what we can say, a unique key based on this product ID and store ID. So that gives uniqueness to where this product was bought and from which store it was bought. Right. So we'll refresh. The inventory table is already available. Then now these tables, all six tables are created. So on day-to-day basis, this table will get new records. Some of the records will be updated, and daily business operations will be recorded in this database. So there is a clear demarcation between what is happening on day-to-day basis, business operations that are happening. And then when we ingest this data into our project, so definitely we'll need to have an area where this data will be stored temporarily. Okay, which can be later on used to perform different data operations. Okay, where we will use all our software engineering principles, okay, to get the quality data out of this data that can be served to the reporting tools. Okay, yeah, so I'll quickly activate my staging database. I'll say use staging underscore db. I'll execute it. Yes, so it's now activated. You can see it is being highlighted in the bold uh, uh, letters. I'll quickly create some space to paste the queries. Now, similarly, of course, the data being ingested from OLTP into our staging DB. So we need to have exactly similar tables. Okay, that will so that we can map the OLTP data to our staging DB tables.